Good day to all of you. Today we shall study BFS and DFS, that is breadth first search and depth first search. These belong to the topic graph traversals. Our sincere thanks and acknowledgement to authors Elise Horowitz, Sartaj Dani and Susan Anderson Freed, authors of the textbook Fundamentals of Data Structures in C. Content of discussion I have taken from this textbook. So what is graph? Graph is a nonlinear data structure. It consists of vertices and edges. The vertices are sometimes known as nodes and the edges are called lines or arcs. These lines or arcs connect any two nodes in the graph. Graph is composed of vertices V and edges E. Hence G of V, E. Hence G of V, E means it indicates graph. G for graph, V for vertices, E for edges. So graph consists of set of vertices and edges. Set of edges, and this is the set of edges for G3, that is E of G3 this is. What is graph traversal? Graph traversal means visiting the nodes in the graph, but each node only once. What are the two techniques of graph traversal? Breadth first search, that is BFS, depth first search, that is DFS. Where these are used? So these traversal techniques, they are used in transportation networks, communication networks, information networks and social network. So social network, if you consider, people are nodes and friendship is an edge. Then information network, so web pages are nodes. The hyperlink between the pages are called as directed edges. Then communication networks, if you take a collection of computers, they are as nodes and physical link between the computers are called as edges. Then a transportation network, if you consider, airports are as nodes and direct flights as edges. So what is breadth first search? It is a fundamental graph traversal algorithm. So it begins with a node. First we traverse to its adjacent. Then all its adjacents are visited. Then their adjacents are traversed. Okay. So close vertices are visited first before visiting others. So we mainly traverse vertices level by level. So the difference between trees and graphs, so unlike tree, graphs may contain cycle. Means in graphs we can have cycle, that is closed loop. In trees there is no closed loop. Where BFS is used? BFS is used in popular algorithms like Digitra's shortest path graph and many more problems. BFS algorithm is as follows. First step is initialization. So whatever source vertex is given, enqueue the source vertex into queue. Means put the source vertex into queue and mark it as visited. Next, exploration step. While the queue is not empty, dequeue a node from the queue and visit it. For each unvisited neighbor of the dequeue node, enqueue the neighbor into the queue, mark the neighbor as visited. Termination step is repeat step 2, this step, till queue is empty. So this algorithm ensures that all the nodes in the graph are visited in breadth first manner starting from starting node. So these are the steps in BFS algorithm. These we can understand when we solve one problem. So let us solve this problem. For this given graph, we'll have to apply BFS algorithm and find the order in which the vertices are visited here. The first step is initialization. Enqueue means put into queue given source vertex. So given source vertex here, for example, we can take 0 here. So, or if any other vertex is given, we have to start from there. Now we'll start from vertex 0. So then when we put it into queue, we'll have to mark it as visited. So whatever we put into queue, we'll have to enter here. Mark it as visited means we'll have to put in this array. So visited is an array of size, the number of vertices. Number of vertices is 5. So size of this visited array is 5. We will go on storing vertex number here. The order in which we store, that will be according to BFS algorithm. So next, vertex 0 is put into queue. It is at the front of queue and it is marked as visited also. When vertex 0 is taken as front, its neighboring nodes are to be considered next. So for vertex 0, neighboring nodes are 1 and 2 because they are connected through edges to vertex 0. So here 1 and 2 neighboring nodes of 0 are put in queue and 0 is taken out of queue and 1 is made as front, means neighboring nodes of 1 are to be found next, and here 1 and 2 are marked as visited. 0 was already marked. So for 1, 2 and 3 are the neighboring nodes. So 2 and 3 are marked as visited, and once consideration is over, it is put out of queue. Next 2 is made as front of the queue so that neighbors of 2 are to be found next. 2's neighbors are 1 and 4. So because 1 is already covered, only 4 is going to be put in the visited array and 1 is out of the queue here, and hence only 4 is put into the queue. Okay, after that 3 will be taken as the front. So only 4 is put into visited array and 4 in the queue, and 3 is made as the front. And 3 was at the front, its neighbors are to be found out. So for 3, 1 and 4, 1 is already covered, so unvisited neighbor is 4, that is put into visited array. Because 3's consideration is over, it is put out of queue. 4 is made as the front. Because 4's neighbor 2 and 3 are already visited, no unvisited neighbors now to put into visited array. So 4 consideration is over, that is also taken out of the queue. Now queue is empty. When queue is empty, the procedure is over, and this gives the sequence in which the nodes of the graph are visited, and all the nodes are visited here, and the node is only once. And this is what is breadth first search algorithm. Nodes are traversed and each node is traversed or visited only once. So let us solve example 2. For this, how BFS search algorithm can be applied, that we can learn. Here the given graph is this. So size of visited array should be 9 because there are 9 vertices in this. That is the first point. Next, which is the source node. If any source node is given, from there we have to start. Now we shall take up A as source node. So A is taken as visited node. A is put into the queue. Why it is put into the queue? This A neighbors are to be listed. So A neighbors are because through links B and S are connected. B and S are A neighbors. So B and S not yet visited in this, hence they are put into visited node list, and they are put into queue because next their neighbors are to be considered. Now A is taken out of the queue B is made as front of the queue means next B is taken to list its neighbors. Because B is front of the queue now, B is considered. It is connected with the link to A. A is its neighbor. It is already visited. Hence we will not put here. And no other neighbors here. Okay. That is why nothing is put into visited node list and nothing is put into queue list. Next B consideration is over. It is put out of queue and S is made as front of queue means next S neighbors are to be considered. So S is taken now. Its neighbors are through links, so it is connected to C and G. Hence C and G nodes are the neighbors of S. So C and G here not yet visited, so they are put into visited array here. Next to find their neighbors, they are put into queue. Now S is put out of queue, then C is made front of queue means C neighbors are to be considered now. So we shall take up C now. So C neighbors are, it is connected through link to D, then another link to E, another link to F, another link to S. There are 4 neighbors. Out of this S is already over. Then because S is already over, the remaining are D, E, F which are not visited, hence they are put into visited list here. And to consider their neighbors next, they are also put into queue. So with C the procedure is over. The next front of the queue is G, means G nodes neighbor are to be considered next. So considering G now, which are the neighbors through link S, another link F, another link H. So S, F, H. Out of that S is already covered, F is already covered, the remaining is H. So H is non-visited neighbor that is put into visited array. Then to consider its neighbor next, it is also put into queue. Now with G the procedure is over. So next front of the queue is D. D node has to be considered. It is connected through link to C, but C is already considered. There are no other neighbors. So nothing to be put into visited array, then nothing to be put into queue. Now with D the procedure is over. The next front of the queue is E. So E node will have to consider. Its neighbors are C, here H. Out of that C is already visited, H is already visited. Unvisited neighbors are not there, hence nothing to put into visited array and nothing to put into queue also. Now procedure with E is over. Next in the queue F is there, it is at the front of queue. So F is to be considered. So F node neighbors are through link, it is connected to C, another side G. So two neighbors are there. G is already visited and C is already visited and nothing to put into visited array and nothing to put into queue. So the procedure with F is over. The next at the front of queue is H. Taking H node now, considering its neighbors, it is connected to E and G. So E and G are already visited, nothing to put into visited array and nothing to put into queue. Now the procedure with H is over. So front is taken out of the queue. The front pointer is out of the queue means queue has become empty. When it is empty, the procedure is over. If you count how many nodes are in visited array, 1, 2, 3, 4, 5, 6, 7, 8, 9. So size of visited array has become 9 and queue is also empty and the procedure is over. So the answer is, this is the outcome of BFS search for the given graph. Okay. Here in the answer you can observe all the nodes of the graph are visited, and any node if you take, it is visited only once. So that is what is graph traversal, and this is the first search algorithm, that is BFS. I hope you understood. Thank you.